Hello out there in internet land once again. Today we're going to be talking about volumes of pyramids and cones. Last time when we talked about pyramids and cones, we did surface area, and we used something called slant height, which, as you remember, is this distance, the altitude of the lateral face, like that triangle. So today, though, when we talk about height, we mean the internal height, okay? But sometimes it's external. It's the distance from the vertex perpendicular down to the base, which you can see there is external. And in class, I'm going to show you why this formula is true, but what you need to know is simply this. We have the formula for the volume of a pyramid is 1/3 the volume of the prism that would fit there. And like I said, I'll demonstrate that in class, but just remember that it's 1/3 the area of the base, capital B, times the height. So let's go ahead and try this now. Here we have, find the volume of a rectangular pyramid with the length 11, the width 18, and the height 23. So it's a rectangular base. Let's go ahead and draw it. Put the dot in the middle, bring that up, and down to each of the corners. All right, so this is going to be 11 by 18, and the internal height is 23. 23. So what I need you to write on your paper, and you're going to go ahead and copy this example into your notes right now. The volume is the area of the base, capital B, times the height. And I've just written the wrong thing there, because we're doing a pyramid. I wrote for a prism, and indeed, we've got to do the one up here for a pyramid. We have to put the 1/3. 1/3 the area of the base times the height. So we plug in those numbers. The area of the base, the area of the base is a rectangle, so it's going to be base times height. And here. And the thing I want you to do is, that's the height of the rectangle, and this is the height of the pyramid, so HP. Don't get the two heights confused. All right, so 1/3, I'm just not drawing very well today, equals 1/3. The base is 11, the height of the rectangle is 18, and the height of the pyramid, 23. And all those units are the same, yep. And here we go, and we're going to type that in. I'm going to do one of these in my head here. I can take 1/3 of 18 and do that very easily and make that 6 times 11 times, what was the other one? 23. And indeed, there it is, 15, 18. And remember, volume is cubic. So there we have it. So that's how we use the formula. I'm going to go ahead and put a copy of this here just so you can see it. There you go. That's how we got the answer. So that's finding the volume of a pyramid. The key thing here is that we need to make sure that we use 1/3 the area of the base, because you can fit 3 pyramids in one prism with the same base and same height. All right, let's move on. Find the volume of a regular hexagonal pyramid with the height equal to the apothem of the base. Okay, so there's a lot of information here. But the first thing I'm going to want to do is to go ahead and draw the base separately. And there is some formula for the area of a regular thing, but the key thing that we're going to want to remember is that's the apothem. And we're going to call the apothem x. This whole thing here is 12, so it's going to be 6. And because this is a hexagon, this is going to be 60 degrees. So this is a 30, 60, 90 triangle. And I'm going to separate that out. 30, 60, and that's 6. So what do we do to the short side to get to the long side? Indeed, that's 6 square root of 3. And they're telling us there that the height of the pyramid is also going to be 6 square root of 3, because it's equal. Tells us that. So let's go ahead and write down our formula. volume equals 1/3 area of base times the height. 1/3. The area of my base is, I got 6 triangles. 6 triangles where they each have a base and a height, and that's the height of the triangle. And then we have the height of the pyramid. So there's my formulas there. If you want to consider that to be the base, and this over here is the height. All right, so let's go plug in. 6 times that. The base of each of these triangles was 12. As you can see here, that's 12. And the height of each triangle, we figured out, was 6 square root of 3. So that's this whole thing here is the area of my base, and the height of my pyramid is right here, 6 square root of 3. So let's go do some simplifying. So 6 times 1/3 times 1/2, that all goes away. And I get 12 times 6 is 72. And then I get square root of 3 times square root of 3 is 3. Finally, over here, I do 72 times 3, indeed, is 216. And these are feet cubed. So there you go. We used our beautiful formula to find the volume of the pyramid. Fantastic. All right, volumes of cones are very similar. It's the 1/3 the area of the base times the height. So it's exactly the same formula. And as we know, with a cone, the area of the base is pi r squared. So it's 1/3 pi r squared times the height. There's no magic here. So let's go ahead and do this problem. Find the volume of a cone with a radius 7 centimeters and the height of 15 centimeters. Give your answer in both pi and round to the nearest tenth. We can do this. We draw in my cone. Stunning. Love that picture. The radius is 7 and the height is 15. Once again, that's the perpendicular height right here. And now let's go use the formula. So, volume equals 1/3 area of the base times the height. And in this case, the base has an area of pi r squared. And now we go substitute in. And my radius was, where is it, right here, 7. And my height was 15. Volume equals 49 times 1/3 of 15 is 5 pi. All right, so let's just do that. 49 times 5, 245. 245 pi. And the units are centimeters cubed. And now let's go get the approximate answer times pi. And that's going to be 769, rounded to the nearest tenth, 0.7. So that's how you use the formula on the basic type problems to get the area of a cone. Very similar to the area of a pyramid. Once again, it uses the same formula. It's just that the base happens to be a circle right there. All right. So I think we've just, oh, this is a pretty good one. Let's go ahead and do this problem. Here, find the volume of the cone. The problem is they didn't give us, we know the formula is 1/3 capital BH. We can find the area of this base, but we don't know the height. So how would we go find the height in that triangle? And indeed, if you said, Mr. Pythagoras, you are exactly right. We need to go find, let's call it H actually. That makes more sense, and that's 34. And my guess is they gave us numbers that work out beautifully. Oh, what happened here? Let's try that again. Plus 16 squared equals 34 squared. And let's go type that into our calculator. So let's do the square root of 34 squared minus 16 squared. Is it a pretty number? Oh, it is. Thank you so much. So the height of this cone is 30. They gave us the slant height, and we had to come find this height right there. That's all we need. We throw it into this. Now we know the area of the base is pi r squared and h. All right, my radius here is 16, and my height I got over here is 30. Now be really careful here. Don't just take half of this 16, and the reason why is because we have to do exponents before we do multiplication. So we might want to go through and do 16 squared. 16 squared times 30 divided by 2. And that'll get us the right thing. 3,840 pi. And these are centimeters cubed. And now the approximate is 12,063, and we'll round to the nearest tenth. So there's a little more complicated problem showing you that we first had to go find the height. We were given the slant height and the radius, and we needed to go find the height, the height from the vertex down to the base. All right, I think we're going to do one more here, and I'm just going to set this one up. Find the volume of this whole figure. And you can see this figure is made up of a cone, a cylinder, and a cone. So that's the way I would want you to write that first. You're going to say the volume is going to be that plus the cylinder plus the bottom cone. Okay? And that's how we would go do this volume. So the volume of a cone is 1/3 capital BH. A cylinder is capital BH. And the bottom cone, once again, is 1/3 capital BH. And they have different heights, so you can't just do two of these things. You have to do them separately. And let's go put some more numbers in. The area of this base of the top part is pi r squared h. Cylinder, pi r squared h. And 1/3 pi r squared h. And now you'll go plug in all those numbers. So that's your hint on how to solve a composite figure 1. We go write out the pretty pictures of each one. We write the formulas. We substitute in what the actual bases are. And now we're going to plug in and solve. So that is the end of this here. And we have learned everything we're going to learn. I'm going to leave you with one last problem, which is a pretty basic pyramid problem. Go ahead then and type either A, B, C, or D, the correct answer, as part of the form, and submit it. And we'll see if you're correct. All right. Thanks so much. We'll talk to you again.